From building system software for hardware appliances in C++ to building data governance software in cloud. This is Confluent Developer.
Splunk is an enterprise software company, much like Confluent, and we had a very serious problem. This was one of the projects that made me realize how different systems need to be able to communicate with each other. We did look at that and realized that that still was not enough.
Hello and welcome to this episode of Confluent Developer. My name is Viktor Gamov and I will be your host today. And with me in our real studio today, my colleague from Confluent, Dhiraj, Suri. Dhiraj, welcome to Confluent Developer.
Thank you.
So Dhiraj, can you tell us, our listeners and our viewers, what do you do at Confluent? And it would be great to learn a little bit more about your current work.
I'm a staff software engineer on the Stream Governance platform team, and
Yes.
the primary focus of our team is a product called the Stream Governance platform, which essentially allows customers of Confluent to manage their schemas and make sure that the data that they have that flows in from disparate sources is compatible across their ecosystem.
Yeah, so talking about schemas and schema registry is probably one of my second favorite subject to talk. Apart from talking about Flink and talking about Kafka, I start kind of introducing schemas for polyglot developers, usually kind of like a Java developer, just like, okay, well, whatever. We're going to do whatever we have, maybe even Java serialization, maybe JSON, but when you start dealing with the systems that written in different languages, you need to come up with the cross-platform protocol to talk.
Yeah.
So in the Confluent Developer podcast, what we like to do, we're exploring origins of technical excellence. How I like to put this, meaning that we are chatting with the practitioners and the people who've been around in building some of the complex systems and would like to learn what they learn over the time. And essentially we like to structure everything around two concepts. One of the concepts is kind of like, what was your first job? How you start understanding that your skills can actually, you can do something with those. And if you have example, how you end up in technology, like for example, what was your first language that you developed, like your software, or maybe something that you developed and you sold this, that would be interesting thing to learn.
Yeah, definitely. My first job right out of college was as a software developer at a company called NetApp. It's still obviously a pretty big company. It's still there. Yeah, of course, it's still there. But back then it was the cloud revolution was kicking off. It was into high gear. I think back then I thought I was unlucky, but looking back, I was very lucky to start my career writing code in C and C++, because I think for any computer science major, that's the perfect language to take off and have your career start off in, because it's about as close as you can get, well, at least in the past couple of decades, that you can get to how a computer actually works rather than a lot of the languages that are around today. So I was writing code that runs storage software on the actual NetApp
appliances.
The actual appliance. And that's when I started understanding the scale of the power of the cloud, really. And NetApp was right on the cusp of being a company in the pre-cloud era, transitioning into the cloud era. And that gave me the perfect opportunity to understand and actually really see what the next couple of decades were going to look like, and here we are.
So you think is C++ still good language for writing cloud applications? Like if you develop a cloud platform?
Certainly. That's a great question. Actually, after my second job, right after NetApp, was actually for a video ad serving platform company called Brightroll. It got acquired by Yahoo, and we were running the entire ad serving stack in C, in web scale C, like billions of transactions a day, or requests a day, really. And we couldn't have done it without C. I don't think the company in the form that it existed.
So you think that the Java will not be able to do some, that's because Java, me in Java, it's everything.
For those margins to work out, we in fact one of the main things I did in my 2.5 years there was to rewrite just one component of the ad serving application, ad serving stack from PHP into C. With the principal goal
I approve that. This is very honorable work to do. And it turns out that the PHP actually it's not that bad. You can actually compile PHP to C with the hip hop and things like that on the Facebook, right?
We did look at that and realized that still was not enough to get us to the margins and the scalability that we needed to.
Okay, so now when I talk to people who start their like a career from learning like a serious like a system level language. Rest of the kind of like world for them is kind of walk in the park. Learn high level language like Java or like learn something or .NET would be much easier, and kind of transition to the different world would be. So what language do you use today?
Well, schema registry, a lot of schema registry is written in Java, as folks listening to this would know. So I do use a lot of Java, and then Golang, obviously, are a lot of for control plane.
Like things, I think that you would agree that with emergence of Golang and Kubernetes, the shift for like cloud software, system software, kind of like shifted, like things shifted into the world where the Go would be kind of a de facto kind of standard for writing those steps.
It's basically become the de facto standard. So to answer your question, I do find it. I think the inverse would have been much harder than going from C to Golang or C to Java. So I do find that. I don't find the complexity of the language to be a barrier for me day to day.
Every time when we're talking about these new cloud languages, we cannot not talk about Rust.
Yes.
What's your thoughts about this? And do you think it is a great tool for writing? Since you already been in the cloud space and touch different system components.
Yeah, I do see Rust being used for a lot of applications. But I as far as I've seen, it's still somewhat specialized. It hasn't broken through to becoming general purpose in the same way.
There was no Kubernetes in Rust yet.
Yes, exactly. That's my point. The same with Golang or obviously Java, but Golang has become.
So one of the things that we also would like to discuss with our guests, and I think you have a great years of experience in this space because you came from the cloud companies. What was the most challenging thing that you ever done? It can be before Confluent and Confluent. What's the kind of a very interesting technical challenge that you solved or you didn't, and you're proud or you're not to talk about.
Now a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show.
Yeah. I think one of the most interesting challenges that I've had to deal with, I think in terms of scale and impact on business, I think when I look back is at my previous role at Splunk, we had a very challenging problem of needing to be. Splunk is an enterprise software company, much like Confluent, and we had a very serious problem with needing to provision customers quickly, large enterprise customers very quickly, and giving them their Splunk deployment, in a reasonable amount of time. And the barrier to doing that was the fact that we had disparate systems across engineering and IT engineering, software engineering, which is our organization, and we had to stitch all of these different systems together in order to produce a coherent outcome for the customer.
Yeah.
And that's when that's where my team, my expertise, having been at the organization for several years, that came into play, and we were able to architect a solution that put together systems like Salesforce using API integrations like MuleSoft, and then other message queue systems that essentially took something that was seemingly non-deterministic, that required a lot of manual touch points, into what eventually became practically a push button provisioning system. And that's what really showed me the importance of having asynchronicity in these large, very complicated enterprise software systems.
Can you touch a little bit about like architecture of the solution? Because our listeners would also appreciate kind of like learning some of the technical details. I guess maybe not super deep if it's some proprietary secrets. It's totally fine. But in general, like let's imagine you need to architect the, I would say that it's kind of self-service portal for customer where they can provision different environments and stuff like that, right? So
yes, that's pretty much it. Yes, I think in terms of really from a high level, what the solution what a solution like that would involve, not without getting into the specifics of that, is you want asynchronicity and really event-driven processing, and really in a way. This is really about streaming data from customers, right? That the inputs that customers give us across different databases, like we were effectively Salesforce effectively functions as a database, and from that you want a queuing system so that their back pressure doesn't actually lead to a backup that users feel. So we had MuleSoft, we had Salesforce, we had a lot of AWS. We weren't using Kafka yet, but we had SQS and SNS a lot. And then, of course, being Splunk, we use Splunk itself for a lot for observability.
So how you think the now you're working with the schemas, and how your knowledge from the the technologies from the past translated to technology that you're working on this today? Like what kind of experience you bring into building data governance tools?
Actually, this was one of the projects that made me realize how different systems need to be able to communicate with each other, right? It's just because it's Conway's law, just because
different departments will be kind of like a correspond or like will be mirror software that you will be implementing.
Correct. Conway's law is sometimes quoted as a good thing, but in my opinion, it's not a good thing.
Depends of the organization, like how everything is established.
You might need to work against Conway's law, right? You don't want disparate systems to be built and then to reside within disparate organizations. You want to break those barriers for the company to grow and serve customers better. And I think something like schema management, it becomes very important when you have APIs that are designed by different engineering paradigms. In fact, forget languages, forget services, right? Different engineering paradigms, and that's where you need API contracts, and that's one of the things that I was very keen on enforcing and really evangelizing within the company on what REST.
Exactly. Open API schemas, like Swagger and all this kind of things.
Exactly. And that really got me thinking about how message queues in the abstract, and specifically something like SQS or Kafka would do very well with having schema management. And message.
I spent a couple of years working in API management layer a little bit. I worked at a company called Kong, and one of the products was like API management, API gateway, and lots of conversations that I had with many customers is how to bridge like API request response approach with messaging, streaming, event driven. Like, what would be your kind of like a take on this? So you spent some time in API integration, and now to like in event driven. What would be be your advice for customers who like to understand better how they move from the request response to event driven?
Yeah, definitely. I think having you want to loosely couple systems,
Yeah.
right? I think in the era of microservices and having obviously like a lot of event-driven and data streaming use cases, especially
these days they're calling these like AI agents.
Exactly. You if you need to have something agentic and really under the hood, that's just about loosely coupling and having event-driven systems, right? In a new form, a new iteration of event-driven systems. I think one of the key aspects of having something like that succeed is to build fault tolerance into it, is to have eventual convergence and asynchronicity built into those architecturally. And that has to be end to end, right? And not just, it can't just be, I'm just gonna have a for loop that just retries 5 times. That won't cut it for once a system gets complex enough. You need something like, if we're talking about under the hood, right? You need something like a Kubernetes operator. If you're trying to, let's say, provision a Kafka cluster. Obviously, we already have CFK. But something else like that. You need a framework like Kubernetes, or it could be anything else that's similar. But you need to build reliability and fault tolerance.
One of the things that we built and we used in our times using the service mesh that provides kind of like a virtualization of networking that allows to define different routes, how the traffic can flow, and also you can have built-in kind of resilience components that allows you to do kind of like the back pressure can do kind of like retries, like you mentioned, kind of like exponential retries if you don't want to kind of like cripple the system constantly, like trying to, you get like a 404 or getting like a 503 and you continue to hitting the system with this.
You don't want thundering herds. Those are definitely bad. And really, there are depending on the use case, there are off-the-shelf tools these days. You have Argo, workflow engine. You have a lot of tools like that, and those are the kind of things that you definitely don't want to reinvent the wheel if there's a solution that exists out there.
It's kind of funny because like we had the episode where we were actually talking the times where the tools were non-existent and lots of things needs to be kind of like reinvented. And today, as like 2025, 2026, you probably will listen this podcast already in 2026. There's a plenty of tools available, and knowing these tools, that's also important. What's your like favorite ways to learn those tools? Like, what's your go-to, the mindset of learning about those new technologies and cloud native stuff and all this type of things?
I'm tuned into a lot of blogs, and I was tuning into Confluent long before I joined Confluent, and on LinkedIn and obviously on
the Confluent blog was known as a resource even like before the Confluent become like the big company. Lots of technical excellence came from
absolutely,
blog.
Absolutely, and the open source community is obviously a big part of how something like this comes to be and then evolves and then expands, right? Which is what Confluent has become. Definitely, I've always been keeping track of the Apache family of projects, and especially, I don't know if it's LinkedIn in particular, but there's been a lot of interesting companies and projects that have been founded by LinkedIn alumni. Obviously this one.
Exactly. It's also interesting for me that like even, I don't know, maybe 10, 15 years ago, people would say, like the projects will go to Apache Foundation to retire or to die. It's definitely not the case anymore. So there's some new projects and they came up in the field of data. There's a lot of like interesting things that happens around like streaming data, data processing. Inside the Apache Software Foundation.
And in fact, I now see Confluent alumni now founding companies that add to this ecosystem, especially in the obviously data streaming and then AI agent use cases. So I follow companies that are doing well. Because that tells you that those tools are useful. To me, that's the easiest way to keep track of, what is the latest out there that I can use. And I knew Kafka before Confluent, but obviously, seeing Confluent itself grow, made me realize the power of Kafka.
So Before we part, I would like to ask you one important question that maybe many our listeners would like to know: Avro or Protobuf?
Protobuf.
Come on, seriously.
It's at the power. I mean, we used Protobuf for ad serving.
Yeah.
Nothing else would compress the ad serving requests that much.
That surprised me because during my some research and for some presentation, I learned that the people in Hadoop world came up with Avro because Protobuf was not able to serve the needs.
In what way?
I think it's all about schemas and how the Avro provides kind of like a write schema and read schema, so you can have a get access to the data, and the backward compatibility treatment is slightly more flexible than in Protobuf.
Absolutely, yes. For that, yes. But given my background of ultra low latency, applications, I think nothing comes close to Protobuf, gRPC, that whole ecosystem.
Yeah, that's great. Dhiraj, thank you so much for being part of Confluent Developer. As always, my name is Viktor Gamov, and as always, have a nice day.